Thank you very much. Do you hear me? Yeah, that's probably better. Thank you very much for the introduction. What I'm going to speak today about. So every big company is at some point confronted with the problem of producing shift plans. Maybe a bit further. Yeah, that's now better, I guess. So the problem we wanted to solve with our optimization software was to produce monthly shift plans. Or maybe I'll take. Is this better now? Yeah, that's better. Okay. So monthly shift plans, that was the goal to achieve. So in other words, imagine you have a set of employees, you have a given demand you want to cover, and your task is now to produce a plan, so meaning to every person and to every day, assign either a shift which that person is going to work or to have off on that day. So in other words, you want to produce such a sheet, such a big sheet, in every line a person, in every column a day, and in the cell itself there will be either an off or what shift the person is going to work. The whole story, I guess I need to move away from the... The whole story started back in 2007, when my colleague Andreas Klinkert, he's with the project from the very beginning, and then back then Swissport company realized or decided to try to produce a software which would automate that step of producing shift plans. Of course, I cannot forget my colleagues from the Swissport company, Roman Berner and Rita Thalmann. Rita is also from the almost very beginning with the project. So maybe just a few words about the project itself. As I mentioned already, in 2007, the Swissport company approached the Zurich University of Applied Sciences with the question whether it might be possible or would it make sense to try to produce a software which would automate rostering meaning producing shift plans, in our case monthly shift plans for the whole personnel of the Swissport. So it started as a Swiss national research project for a couple of years. It was paid by the grant agency, and later on, when it was clear that actually it's going to work and the software is going to produce shift plans, it became a strategic research and development cooperation between the Swissport and Zurich University of Applied Sciences, and it's at least we think it's very successful, and Swissport, I guess, thinks the same. The aim was to provide an efficient and flexible optimization software for complex, large-scale rostering problems. At the start, maybe just for the Swissport itself, but later on also for other ground handlers out there, and maybe even for other industries, because as I've mentioned, every big company at some point is confronted with that task anyway. Very few words about the Swissport company itself. It's the largest international ground handler. It's active in 45 countries, 850 airlines are the customers of Swissport, so it's really a huge company. Who are actually employees of the Swissport? Who are these people? What are they doing? And mainly, these are all the people working at the ground, at the airport, who are somehow connected to passenger services or to ramp services. So passenger services like check-in, gate, lost and found, or all the guys at the ramp caring for the luggage that it's on time for the flight. So how actually back then in 2007, how did it work? What was the starting point of our collaboration? So in other words, what are the steps you need to do in order to end up with a monthly shift plan? So where does the demand come from? The demand you want to cover is actually given or implied by the timetable, by the flight schedules, when which flight is going to arrive, when which flight is going to leave, to depart. And to that are tasks coupled. Somebody needs to sit at the check-in, somebody needs to be at the gate, somebody needs to care for the luggage. These tasks are then going to be put together in order to produce shifts which have to have a certain length, maybe 8 hours or 6 hours or even 4 hours for some students who are working at the airport, whatever. Then, so you have a set of shifts you want to cover on a certain day. These shifts need to, of course, in order for an employer to be able to work a certain shift, he or she needs to have the corresponding qualification. And then what you want to do is, in the end, to decide for every single person, he or she, on a certain day, is he or she going to work or not? This is this first step, this days of planning. I'm deciding whether that person is going to work on that day. This is, so it's, let's say, an optimization problem of itself. Then you could fix that information and go on to the next step, to so-called shift assignment, where you take now these people which are going to work on a certain day and to assign shifts to them. Shifts that need to be covered. But of course, you need to follow some rules. You can assign only a person who has the corresponding skill, the corresponding qualification. You need to think about many regulations, like a person cannot work more than 6 days in a row. A person cannot work more than 50 hours per week. A person needs to have at least 11 hours rest time between 2 shifts. So it's much, much more than that, just to mention a couple of them. And in the end, what you would like to have is such a monthly plan. So this is something which happens like 1 month in advance. So it's a monthly plan which is going to be published. The employees have the chance to look at it, to maybe to switch some shifts. And maybe something happens in between. Somebody becomes ill, or or a change in the flight timetable on a very short notice. So you don't know what's going to happen, and then on the day of execution, you are again confronted with something, with a problem you might have to solve. So how is it now? How does it work at Swissport? What was actually the starting point back in 2007? For task generation and shift construction, they have a software coming from Inform. It's called GS Planning. Then this rostering step, where you actually need to produce these two, need to fulfill these 2 steps. Back then, Swissport was doing it manually. So you need to imagine they had like such a planning board, which is, let's say, a table where you could, in the table, every line corresponds to a person, every column corresponds to a day. And now you are asking yourself, what am I going to put into that cell? There is also a software called WebRoster, which actually is intended to for the employers to be able to put in wishes. An employee can put in wishes like, I would like to work on that day just a late shift, or on another day I would like to have off, or maybe this weekend I need to have off, please can you do that for me? And then this planning board, I'm going to show a picture on the next slide that's coming from Interflex, that's SP Expert. And the last step, this real-time dispatching, that's again a software coming from Inform. So you see this manual step. I'm going to come in a minute to how expensive it was, how much time did it cost. But anyway, that was the starting point that Swissport realized that manual rostering is probably not the best thing to do. And that was also the opportunity for us to, so that was the idea of Swissport. Let's try to produce a software which is going to automate that. So the idea was that some data regarding personal data regarding the demand is going to come into the program. Then you push a button, and in the end, hopefully, a plan is going to come out, a valid plan, a working plan, which fulfills all these regulations about rest times, about maximum working days, about all that stuff. And at the same time also is going to try to fulfill all these wishes coming from the employees. So as I mentioned, it started back in 2007. It took quite some time in order to bring it to run, that actually it was able to produce some kind of plan. To build up a new model, completely new model, a big complex model out of nothing that actually needs some time. And also at that point, nobody could have given a guarantee that actually in the end it will be working. So from this point of sight, it was very good, or very for us very lucky opportunity to show and to try what actually are we able to produce. So this is this mentioned planning board, how it looks like. So here you see on the in every line you have a person, in every column you have a day going from 1 to 31. And so for every line corresponding to a person, you have 3 separate lines. So the first one is the wish the person put in. The second line is what the planning tool or the planner put in. And the third line is actually what did the person work in the end, because of this real dispatching step. So you see it mostly it is the same, but at some point you also see differences. So here something happened. This person probably needed to work because, I don't know, somebody else became ill or something. Nevertheless, this planning board gives you no support in optimizing anything. It's able to tell you, okay, there is a rule violation, you cannot put into more than 6 days of work into a row, but it's no support in optimization such that you would like to get a nice plan or a good plan in whatever sense you are going to define. So how did it work? You need to imagine it was up to 20 planners, and these 20 people have done nothing else the whole month than to produce a plan for the rest of the employees for the next month. So it's like 230 days per month planning effort. Okay, it's a very tedious work. It's a very maybe even boring work, and at the same time, the planners were did care very much for the employee wishes, so they wanted to fulfill them on a very high rate. And that was possible because they knew their employees. So it was small departments every planner was assigned to, and they knew their people, they knew who likes to have what. Anyway, but on the other side, it was also a minus point, because every single one of them, at first they needed a long special education, long time experience, and but they somehow, everyone had his or her own recipe how to do that. How to start, how to produce a plan, maybe also depending on the department, because every department is a bit different. And also they had different opinions on what actually is a fair plan. And what is a good plan? What does it mean that a plan is good? So in the end, what was present was an expensive way to produce monthly plans, which included a lot of work. It took a lot of time, and it was very subjective. Every single planner produced what he or she actually liked and thought it would be a good plan. So about how many people are we speaking? In Zurich itself, it's 2,000 plus employees. We have also big planning groups, up to 1,000 people. We have also small planning groups with just, let's say, 20 people, and hundreds of types of shifts and hundreds of qualifications. Now you might come up with the idea, okay, let's produce such a pattern, shift wheel, which we are going to repeat. But that actually does not work because when you think about the airline business, it's completely different on Christmas, it's completely different in the summer, it's completely different in October in between. So this demand, it varies very, very dynamically. And the first step the Swissport company has done was to look around. What is out there? Are there already softwares? Are there rostering tools which could give you good support in producing monthly plans? And what they find out that most of them were able to produce a plan, but it could be that the plan wasn't feasible. Some of the conditions, some of the constraints, the software was not able to fulfill. Or the conditions they wanted to incorporate, the conditions which were really needed, were really too complex that the tool itself was not flexible enough. So the conditions were not representable. Or the problem was too big, not able to come up with the solution in a given time window. And that's a big issue. You had no information about actually how far are you away from a good plan, whatever that means, a good plan. So you need at first some criterion which defines what's a good plan. But then, even then, if you have that, you have no information about the so-called optimality gap. How far am I away from the optimum? What is the potential still present which maybe I could use? And okay, you have no bottleneck analysis, you have no rapid rough cut planning in order to realize, okay, is my situation for the moment okay? Is my demand okay? Or need to I adjust on the demand side, whatever. So these, most of the rostering tools, rostering softwares work with meta-heuristics based on stochastic search. That could be tabu search, simulated annealing, or genetic algorithms. And typically they produce, because they are meta-heuristics, they produce something which hopefully is feasible, but this guarantee is not given. It can be what's behind that. That's why, actually, why does it happen? Why cannot you guarantee the feasibility that all your conditions are fulfilled? Because they don't exploit the mathematical structure of the problem. So this is the big difference. Our tool relies on exact methods. So in particular on mixed integer linear programming. So what we have, we produce a mathematical model. That mathematical model consists of a criterion we would like to maximize or minimize, depending what it is, and also of conditions, so-called constraints, which actually somehow represent all these regulations and rules you have to fulfill. Of course, you need to choose suitable variables, and then with these variables, you are hopefully able to come up with a mathematical model which represents these conditions. When dealing with a explicit this description of the solution space, what you end up with is a mathematical model which you can solve then with a solver, and we are also very grateful to Gurobi that almost every year a new version is coming, which also makes our work a bit easier because the runtimes go down. Anyway, what's really an issue and a big issue, this is this good polyhedral formulations of the constraints. Maybe I'm going to try to explain it in a few sentences. Typically, when you are solving a linear program, you have a polyhedron. So it's a linear structure consisting of edges and vertices, and typically your optimum will be somewhere in a vertex of that structure. When you are dealing with integer programs, which is very often the case, imagine that you use binary variables representing some decisions, yes or no, then automatically your optimal solution is not bound to these vertices anymore. It can be also in the polyhedron, in the interior of the polyhedron. So actually your description of the polyhedron is not nice in the sense that you cannot use methods. You cannot use methods which are used to solve ordinary linear programs like the simplex method. And what you can try is to, geometrically speaking, to make that polyhedron a bit smaller, such that in the end you end up with something where indeed every vertex has integer components, meaning that it's not an integer program for you. You can eliminate the integrality condition, and then you just apply ordinary method for linear programs, and you are fine and you are happy. So that would be a good formulation where your vertices have integer components. To come up with such good formulation, that's really tough work. It's deep mathematics behind that. For many problems, it is known how such a formulation does look like. For many other, you don't know. You don't know. And it's even worse in the sense that when you start to build up a constraint, very often it happens that the easy, simple, intuitive idea which brings you to a constraint is actually not of the sort of the good ones, it's the bad one. And these good ones, they are typically anti-intuitive, they are much more complicated, they look strange, they look very, very different. But these are the good ones, which can actually bring you very far on your way towards an optimal solution. So from our experience, I can tell you that a certain module where we were looking very intensively for a new formulation, and we ended up with a model where the saving on the runtime was over 90%. So these good formulations, that's really something important, and it's really an issue. But for that, you really need a very deep understanding what's going on. So other techniques we are using is, I mentioned it already, decomposition, where you try to not to just solve just one optimization problem, but actually chain of optimization problems, where you at first solve the first one, look at the solution, fix that information, and go on. This is one approach how to deal with that. Another approach we are using are relaxation methods that goes into direction of soft constraints. I mentioned hard constraints which need to be fulfilled because they are coming, for example, from the labor law, and you need to have the guarantee that indeed they will be fulfilled. And the soft ones, these could be, for example, the wishes of the employees. The company would like to fulfill them, but if it's not possible, okay, then not. But what you would like to have, let's try to fulfill them. If it is not possible, there will be a penalty for that. Then you can sum up all these penalties. That could be, for example, a criterion for a nice plan. These penalties, the sum of all these penalties should be as small as possible. Where these penalties do come from, that's another issue. So it's really tough thing in order to come up with numbers. It's actually certain numbers which need to represent how bad it is to not to fulfill that condition. How strongly should I penalize that difference which is caused by the fact that my condition is not going to be fulfilled. So what's going to happen when you are going to apply such an exact method? So with a meta-heuristic, you still have the possibility that in the end, your plan actually won't fulfill all the conditions. But this is not the case with this exact methodology. If you are going to write down a mixed integer problem and solve it with Gurobi, then you can be sure that your plan fulfills all the conditions, all the constraints, and that's good. This is what we want to. But there is another possibility. There is also the possibility that these conditions, that these constraints are so tight, your demand is too high, or you don't have enough people, or you have too many shifts, such that in the end, Gurobi tells, oh, sorry, the problem is infeasible. We don't have any plan which would fulfill everything at the same time. And that's again an issue. What are you going to do about that? Because if you think now so if you would ask a planner, what would you like to have? A rubbish plan which does not fulfill certain conditions, or no plan at all because it does not exist? So the planner would say, of course, give me the rubbish. But he's not or she is not satisfied anyway. But how to deal with that problem? What can you do? What can you do? And luckily, Gurobi provides hints to infeasibility. So if you end up in the situation that your problem is infeasible, Gurobi is going to produce a minimal set of contradictory constraints. That itself is again an optimization problem. That itself again can take some time, but in the end, at least you know what is your problem. The problem can be then, okay, you know, there is an infeasibility caused by a contradiction between two constraints. You adjust that, you fix that. That infeasibility is away, then you push the button again, and it's again infeasible. So what is going to happen then? This minimal subsystem is a very nice feature, but on itself, it's not yet enough. What you could do is to go to brute force approach, and to try now from every constraint you would produce a soft one with corresponding penalties. These differences, these slack variables you need, they in the end you hopefully end up with a solution, or maybe not because it's too it takes too long. But anyway, it could happen that you have no idea what actually these slacks mean. So what might be a third option, and from our experience is the best way how to deal with infeasibilities, is to try somehow both at the same time. So you try to decompose the optimization problem into smaller steps, and in every step you somehow apply this brute force approach where you come up with the needed slacks, you solve that, you fix that information, go to the next step, and so on. But anyway, it's a high effort for development, high effort for programming. But this is, from our experience, the best way how to deal with that. If you ask me, does it happen often that your program is infeasible? So for us, it's very often the case. Very often, usually you don't have enough people, or you have too many shifts, or there are other factors which contribute towards that typically your situation is that at first your model is infeasible. When I would have to now quantify how much time did we invest into dealing with infeasibilities, it would be, let's say, 40% or even more. So how does our MIP model look like? How big is it? Just to have an impression about the size. It's 30,000 lines of MIP code. It's done with an algebraic modeling language called linear programming language. That's, again, a software produced by Tony Hürlimann. Next to the MIP model, of course, you need also a lot of Java code. For what? For data handling, for controllers, adapters, heuristics, and so on. And again, another 30,000 lines. How big are our models? So the biggest instance is, let's have a look, it's 450,000 rows, meaning that many constraints, up to 1 million columns, means variables. And in this matrix now, we have 21 million non-zeros. This is before Gurobi pre-solve. Gurobi offers such a routine which actually before the solution process starts, it looks which constraints are actually not really needed because they are superfluous, or they can be they are implied by other constraints. And this pre-solve eliminates constraints and variables. And what we end up typically is with 130,000 constraints and 220,000 variables. Most of them are binary variables, and you see even the non-zeros in the matrix, it falls by 90%. So what we want to have is an optimal solution, meaning that we are sure that in the end, that solution coming out of the Gurobi solver is proven to be optimal. But sometimes it's not possible. Sometimes it takes too long, or the problem is too complex, or and then we need to end up earlier. But anyway, what we want to have this optimality gap very, very small. This optimality gap which tells me how far away I am from the potential optimum. Why that small? So this is again an experience we made. These first 99% actually. If you stop a calculation after, and you know your optimality gap is still 1%, you take the plan, you go to the planner and ask, what do you think about that? And they say, no, that's rubbish, forget it. So it seems that these 90%, okay, you need to do them, but they are still not producing the good plan. The good plan is coming out of the very last percent. A really good plan with regard to fairness, to all these penalties, to the balance between the soft constraints, and depending also how big the department is, we are calculating it. It can be anything between 2 minutes and 70 hours. But that's not a big deal because it's a monthly plan. We are going to calculate 1 month in advance. So that's why, okay, 70 hours, that's like quite some time. But if you, in the end, have the guarantee that this is your optimal plan, then you are happy. So the computation time is still a permanent challenge for us. And this is... Another challenge is that you have a lot of fluctuations between the department groups, or even within one group over the time. Different situation, Christmas, different in the summer, different in October. So where does the software work? Where is it rolled out? It's in Zurich, Geneva, Basel, 57 departments. We have many features like alternating, for example, where you try to ensure that, for example, you have a shift which is very difficult to work. It's very exhausting, or I don't know what. Then you don't want to give that shift to the same person one day after another. You want some alternating, such that in between the person can do something else. What about the wishes? With our tool, we are able to fulfill the slot wishes and off wishes with 98 up to 100%. So that's fine. That looks good. And okay, at the moment, we are at a web application. This is almost finished and going to be rolled out very soon. What about the savings? When we are speaking now about these 4,500 employees in Switzerland, it's 1 million Swiss francs per year. And but still, the model is going to be there are new features going to be introduced, which make the model even bigger, because there are no new contracts or no new features Swissport would like to have. But again, when you are thinking about new constraints, you again need to think, how is this going to play along with all the others? So what did we learn, or what is our conclusion? That there is no satisfactory commercial software out there for complex, large-scale rostering problems. That our approach based on mixed integer programming can guarantee that you end up with a feasible solution where the hard constraints are fulfilled. That we have high-quality results, that we can be sure about the hard constraints. Of course, we have significant savings, but still dealing with the computation time, and still a big issue is these infeasibilities which you need to care for. So this is indeed something very important, and you need to pay a lot, or you need to invest a lot of energy to be able to deal with that. Okay, that's it from my side, and please don't hesitate to ask questions.
Hello.
Yes, hello.
Thank you for the presentation.
Thank you.
You mentioned about the penalties, that it's
Yes.
challenging to calculate them. So what is your approach usually?
That's a really tough question, because it's, yeah, somehow it's not that we are really calculating them. It's rather a thing of experience. So you need to speak to your planners very much, and you would ask them like, what is worse? If I give that person one more working day, or the other option would be that he or she needs to work on Sunday. So you are somehow comparing the badness of 2 or 3 or 4 things and try to come out with a number which is quantifying this badness. But again, we spent a lot of time in order to come up with numbers which fit together and somehow still work. Because if it doesn't fit together, then your plan will be perfect with respect to some constraint, but with respect to another one, it will be completely rubbish. So yeah, I cannot give you a better answer than that. It's you need to speak to the customer that much that you understand how he is thinking, and how bad which violation is. This is the only what I can say.
Thank you.
Yes?
So I have 2 questions. So
Yes.
One is, have you considered the approach of, instead of potentially giving a solution with some violation, let's say, or just give a solution that doesn't cover all the shifts, let's say. So you have an empty shift somewhere, and then it is up to the user to solve it manually. Like
okay, that goes into this rough planning. If you realize, okay, there is many shifts which are not covered, then you probably go to the planners and ask them, how can we do something about the demand, because it's not going to work. Yes, but anyway, if the demand is fixed, then it's a no-go. It must be covered, everything somehow. The worst thing which can happen is, okay, your own people, that's not enough. You need to somehow buy in some, maybe you can get some work from somewhere else, but not from your own employers. This is the worst thing which can happen. That's quite expensive, but if nothing else works, then this is what they do.
Okay, and the second question, you said there were savings about 1 million Swiss francs a year.
Mm-hmm.
How do you measure this? Like how can you guarantee that because you're using this, you are saving money? Because of what you said, that sometimes you need to hire extra people, or because the savings are that in theory with the same people, you cover more shifts, right?
This is not a good question for me. I would have to ask my colleagues from the Swissport. How did they measure that? That's a statement coming from them. So I guess okay, you don't need that planner stuff. So they are doing something else typically. So of course there is still some some work needed in order to prepare the data and so on, but definitely not that much as before. That's one point which contributes to that saving, and the other one would be really that you are able to cover the plan with less people, because the optimization gives you that possibility. I guess maybe they would say something else. I don't know.
Okay, thank you.
Okay.
Yeah. Thanks for the presentation. It was really nice.
Thank you.
My question is more towards you spoke about the soft constraints, whether to fulfill or not the demands from the employees on shift bidding that you had mentioned in the presentation.
Yes.
So my question is, how did you, if you face the challenge of model basically showing bias to any one employee, for example, let's say there are 3 employees who have asked for some changes in their shift, but model prefers one and fulfills only one
Sorry,
employee.
what was it again? Can you repeat it?
My question is more on how did you resolve the bias between the employees? For example, the solution that is given by your optimization model.
So what we care very much about, I'm not sure if it goes in towards your question, we pay very much attention to fairness, that everybody gets more or less the same amount of nice shifts, not so nice shifts on weekends, this fairness aspect, this fairness is very, very important, and it's for us really important, and something we want to be really devoted to. Thank you.